Number 13, a radar used to detect the presence of aircraft receives a pulse that has reflected off an object 6 times 10 to the minus fifth seconds after it was transmitted. What is the distance from the radar station? So you got to pretend, here's a radar station, and what's happening is some wave is being sent out at some speed, right? It's going to hit an object, and then that wave is going to come back and then be perceived by the station, okay? So anytime, in terms of the nature of this problem, they're giving us a time and they're asking about distance. So I'm thinking to myself, well, how are the two related? Well, maybe they're related via the velocity, right? The velocity is equal to the distance traveled divided by the time. Technically, it's displacement, right? I know you're probably screaming at the screen right now. So it's displacement over time. However, though, I'm going to look at this from a speed perspective. So we'll say speed is equal to the distance over time. All right, this is displacement, and this is displacement, and this is now the distance, all right? So what's the speed of this electromagnetic radiation? Well, it turns out to be the speed of light. So we know this. How long did it take? Well, it turns out that we know that, right? So now we just have to be very careful, okay? We know how long that it took the wave to travel to the object and then back. All right, that's the key. So in other words, the time that we're going to plug in here, when we plug in the speed, it's 3 times 10 to the 8. When we plug in the time at the bottom and we plug in our 6 times 10 to the minus fifth, this is the time for a round trip. A round trip. So in other words, it went from the start to the end and then back to the start. Now, if you consider this to be then the total distance, the time that we're talking about here is 1D and then 2D. So it's the time it took to do 2D, all right, in terms of distance. Now all you have to do is, since I want to find just the distance in separation between the objects, I can just simply solve this for D. Cross multiply these two, and that's going to work out to be then 2D will be equal to 3 times 10 to the 8 multiplied by 6 times 10 to the minus fifth. This is about 18,000. Divide that by 2, and it works out to be about 9,000 then meters. All right. So just be careful. This goes back to, consistency. Whatever time value you're putting in here, that's the distance you're going to be calculating. So if it's the time that it took to go to the, aircraft and then come back, that's also the distance you have to plug in, 2D. Guys, thanks for tuning in. I really do hope that helped. Check out some more of our videos. Also, if you're taking pre-calculus or chemistry, general chemistry, either now or in the future, we have solved solutions. So what might be beneficial is go to OpenStax, even if you're not using their book. Download the textbook, find similar or identical problems to the ones you're having, and you'll have answers, all right, of how to do them. Be well.